This video will cover Unit 2 Atomic Structure, 2.2 Electron Configuration for the SL topic. The question asks to write the condensed electron configuration for an atom with the atomic number of 29. Looking at the question, we know that we need to write the condensed electron configuration for an atom with the atomic number of 29. To explain the concept, I'll look at Section 6 of the Chemistry IB data booklet. Now, the electron configuration is how electrons are arranged depending on their orbitals and energy levels, filling the lowest energy first up to the highest energy. Now looking at this table here, we can see that the s orbitals are this yellow part over with the alkali and alkali earth metals. The p orbitals are with the majority of the nonmetals, metalloids, and some transition metals. And the final piece of information that you need to know is that D takes up the transition metals. F does not need to be known for standard level. There are two main ways of writing electron configuration. First is the full electron configuration, and the second is the condensed electron configuration. To write the full electron configuration, we would start off with one s2, as s has two spaces for electrons. Then it would go to 2s2, then 2p6, as p has space for 6 electrons, then 3s2, then 3p6, then 4s2, and then once it reaches D, it would have 3d10, as D has space for 10 electrons in their orbitals, and then 4p6. This would keep on going down, filling up the higher energy levels. And the numbers come from the numbers going along here. So starting from 1 to 2 to 3 to 4 all the way down to 7. Now for example, if we were to write the full electron configuration of boron, we would start off by writing 1s2, 2s2, and 2p1. The 1 here represents this number over here, and the 2 represents the electrons. And as you should know, the s represents the type of orbital it is in. However, there are two exceptions to this rule when filling out the energy from lowest to highest. These are chromium and copper. With this, instead of fully filling the 4s2, you would fill up the 3d instead. So for example, this is the electron configuration of chromium. So instead of writing 4 at the end, 4s2, 3d4, you would write 4s1, 3d5. Now when writing the condensed electron configuration, you will use the noble gases as they have full orbitals or full valence shells. This means that instead of writing aluminum in the full electron configuration, you can write it as neon with the addition of the rest of the orbitals, which would be 3s2 and 3p1. Now, applying this to our question, we know that the atomic number is 29, which is copper, and we know that copper is an exception. So with this, we will have to write copper by looking at the closest noble gas before copper, which in this case is argon, then writing the next orbital, which is 4s1 in this case because it's an exception, then doing 3d10.